types of cylinder is located. On the bottom there is very rigid one, and on the top we have very rigid one is there. Okay, in this case, when you give some force, external force P like this one, P like this one, then what's happening? When P is acting like this one, P is acting like this one, total two cylinder is changed, total length is changed, because external force. Then we would like to know this delta value. And what's happening inside the cylinder is S steel, outside the cylinder is copper. When you cut here, cross-sectional area is like this one. Inside steel's case, cross-sectional area is AS, outside is AC. Okay. Our goal is to find total change of length L and force PS. In order to solve this problem, let's consider a free body diagram like this one on the right side. When you think of the cover, top one, then external forces P is like this one, and PS and PC. PC value is like this one. PC is given. This force and this force. When you sum both of them, this one is PC. You can say PC value. You can separate PC and PS. PC is what? Which is act on to steel inside one. Outside, PC is outside one, PS is inside one, sorry. Okay, when you draw like this one, then on the left side, automatically you can get this one. Okay, in order to get this one, delta and PS, we would like to apply force equilibrium and geometrical compatibility as well. At first, the force equilibrium, when you think over here, positive, then minus P plus PS plus PC equals 0. Okay, when you consider positive one. Okay, next one. Let's say consideration of delta value. When you consider delta, inside delta S equals E S A S, and the length is the same, and P S. Of course, ES, AS is given. PS, maybe you can calculate that. Then finally you can get delta S. Or delta S, you know that. And another one, in the case of delta C, copper's case, PCL over EC AC. Okay. And we have geometrical compatibility. Outside one is rigid body. That's why when you give force, external force like this one, change of length, that means delta S and delta C is the same. Okay. Delta S, delta C is the same. Okay, based on this requirement, 1, 2, 3. This one is maybe delta. Finally, you can get. Based on this kind of requirement, based on this kind of consideration, you can calculate relationship between PC and PS. Okay. Then PC and PS, if it is substituted there, you can find finally delta value and PS value as well. In this example, we deal with the temperature change related to temperature difference. If you have some material which has length is L, let's say alpha is thermal coefficient, linear coefficient, thermal coefficient. Then when you have temperature differences delta T, then when temperature changes, then eventually it can be changed somewhat delta L. Delta L is what? Alpha L delta T. Based on this formula, you can calculate the change of length due to temperature. This one is thermal expansion coefficient. Thermal expansion coefficient. Okay, now let's think about this problem. In this problem, we have inside bolt, one bolt, and outside some sleeve. It's like this one, bolt and sleeve, and it is combined by here washer was used and some nut. Okay, when you rotate nut, you can assemble both sleeve and bolt at the same time. Maybe you can turn somehow, then some point you can stop and properly assembled to some point. Okay, in that point we will consider. And thermal expansion coefficient outside the sleeve is alpha S, inside bolt is alpha B. And when temperature changes, delta T, let's say temperature increased, then it's getting longer. When temperature is going down, then it's getting shorter. Okay, total length is L. Then our question is, we would like to know delta S, what's happening in sleeve, and delta B, sigma B, sleeve and bolt, and what's change of delta. We would like to know that. Now, it is at the moment in the state of equilibrium, but when temperature is going up, what's happening? When temperature is going up, without any restriction related to washer and bolt system, outside sleeve is getting longer, and inside bolt is also getting longer. But the difference, there's some difference like this one, because the material itself is different. Both materials are different. That's why we have different kind of thermal expansion coefficient. Okay, we can consider like this one, but due to some constraint, we have finally some kind of equilibrium like this one. At this point, it approaches like this one. What does that mean? It is connected. Both movement change is connected or constrained to each other. There's some constraints in each other, and finally it's like this one. Okay, that's the process for this one. Okay, now let's think about step by step. At first let's think about final form. Okay, finally we approach this kind of equilibrium. Let's say this one is delta value. Delta is what? Delta is delta 1 minus delta 3. Delta 1, this distance, and outside contraction was happened, delta 3 minus delta 3. When you consider here, inside 1, delta 2 happens by thermal expansion, temperature difference, and delta 4 happens by outside sleeve plus delta 4. This one is what? Based on geometrical compatibility. Okay, now let's think about change of its length. Change of its length. Change delta L is what? Delta L is delta L C as a sleeve, in the case of sleeve, alpha C and distance L delta T, in this case delta S. LS. We can say this one is delta S. And delta C case, sorry, delta, this one is S, delta S, because we used substitute delta S. Delta C equals alpha C, L is same, delta T. Okay. We can consider this kind of relationship, delta S and delta C, delta S and delta C. Okay, this one is delta S is what? Okay, we can say here delta S is what? Delta S, sleeve's case is delta 1. And delta C is inside bolt, inside the bolt. Bolt is changed delta 2. Bolt is changed like delta 2. Delta 2 is changed like this one, delta 1, delta 2. And next step, okay, it was happened by temperature change. Next step change to here is due to some elastic deformation. In that case, we can consider some other relationship. Delta 3 happens. Delta 3 is outside 1. Outside 1 is what? Delta PS. And distance, let's say L, because it's very small. This change is very small. And ES and AS. Delta 4 is what? P bolt L and EB AB can be happened. Actually, it affects each other. That's why some force PC and PB is same. PC and PB is same. We applied many things. Firstly, geometrical compatibility relationship and some temperature change due to temperature change, delta 1, this value, delta 2. Okay. And delta 3 and delta 4 is what? It was happened by some reactional force. Delta 3 is outside. Delta 1, that means a sleeve. Okay, delta 4, inside the bolt. Actually, we can have this kind of relationship. Okay, we have this kind of relationships. And finally, when you calculate, then sigma s equals what? PS AS. If we know PS value, then you can calculate sigma s. PS can be obtained through the relationship, this relationship, and this relationship. You can calculate PS value. If you know PS value, finally you can find delta value as well. Okay, that's for this example. Okay, here temperature, due to temperature change, we considered about change of length or elongation. At first, due to temperature change, it was happened like this one, and after that, some elastic change due to reaction force between two components. Then happens like that. Finally, it reaches some equilibrium point. Okay. Based on geometrical compatibility, we have this kind of relationship, and when you consider some value by changing of temperature, then you can have this one, and elastic deformation, you can have this one, some relationship, and finally you can calculate sigma s and delta value as well. Okay, let's think of another example. In this example, we have a copper tube and outside steel cable. Steel cable and the copper tube is assembled, both very rigid plate, and it is in the state of equilibrium. In this problem, we can use some equipment related to change its length, turnbuckle. If you give a big force, turnbuckle, when you rotate it, the cable is getting shorter. When table is getting shorter, then at the same time, inside copper tube is also getting shorter. Our goal is to find final shortening of the tube inside copper tube, and in between we would like to know force PS and PC as well. Okay, at first let's think about turnbuckle. When you turnbuckle here, we have 2 points, 1 point there, 1 point there. When you have a pitch is what? When you rotate one revolution, the movement is pitch. The movement amount is pitch. In this case, you have two systems, left and right. When you rotate one pitch, then total change is 2. One turn. The movement is 2p. If we have n turn, then 2pn amount. 2pn amount is what? Change of its length, let's say delta 1. When you change n turn, at first its change of amount is delta 1. Okay, that's the first step. If this happens, next step, it is connected by rigid plate to copper tube. Copper tube is connected. Then it transmits some force to the copper tube, and finally copper tube is getting shorter, and finally to reach some kind of equilibrium. Okay, delta 1 was given, and finally it reaches to this position, and that is what? At this position, delta 1 is big one, and when you have some value minus delta 3 value, this one is what? Delta 2 plus delta 3 is delta 1. Not delta 2, sorry. Delta 2. Delta 2 is this distance. Okay. Anyway, delta 1 is delta 2 plus delta 3. Okay, this relationship. Here, delta 1, delta 2 is actual change of length. for each step. And now let's think about the stress related to delta 2. Delta 2. Delta 2 is what? Delta 2 is what? This distance is what? Change of its length outside still ES, AS, ES, AS. And let's say this distance is L, and P, S. Delta 2 is given like this one, L, ES, AS. And next step, delta 3, same. Delta 3 is this amount. This original place, this contraction was happened, and E, let's say copper, PC, L. Okay, you can derive this one. And we derived geometrical compatibility, and we have this kind of relationship. And finally, when you calculate this one, we can find PC and PC, this value of PC and PS we can calculate. PC and PS we can calculate. And final shortening, we would like to know that value is shortening is delta 3. Shortening. Original position to final shortening is this distance. We can have this kind of one. Okay, here to understand properly what kind of mechanism you have related to pitch. Pitch is when you rotate one revolution, the movement of a thread is pitch. If we have n revolution, then Pn, and we have two sides, one or two thread. Then when you turn one revolution, then 2p happens. Okay, this one is what? Geometrical compatibility, the relationship between force and displacement. Then we can calculate PS and PC and delta 3 as well. Okay, in this example, let's think about strain energy, which is stored in the component during elastic deformation. Strain energy is actually defined by this formula. On the left case, A case, strain energy E, let's say A equals 2EA P squared, let's say L. Here A is what? 5/4 D squared. That's the strain energy in first case. Second case, we can separate each one. EB equals like this one. Here P, we can separate this one. Let's say this one is A1 or EA, small a. Okay. Here diameter was changed. Okay. This one 2E A equals 5/4 to the squared. This one to the squared. And distance is L minus P squared, L minus L/4, that means L P squared L, plus 2E 5/4, diameter is D squared, d squared, then P squared L, this one, L 5. Okay, next one. In the case of C, 2E 5/4 2D squared, and P squared L is this total distance is L, okay, plus 2E 5/4 D squared P squared length L over 15. That's the strain energy for each case. Okay. When you consider diameter and length for each cases, then you can calculate strain energy like this one. Here also you would like to calculate the strain energy on the left side and right side. The difference is the P. On the left side, we must consider self weight. Self weight means it's a kind of continuous system, and self weight should be considered. Okay, now consider at this point, draw free body diagram. Then this distance is dx. Let's say the force acting up to here x, and the force acting here is what? Let's say cross section is A. Then means the length from here to there is what? L minus x. We would like to calculate the volume. Then this amount of volume. This volume is acting downward. And this one is volume, and weight density is gamma. Gamma is giving gamma. Then this force is acting there when locates x position. Okay, for this element, we can think of strain energy dE equals 2E A and P squared L. P is force is like this one, and gamma L minus A and X let's say A. Squared distance dx. Okay, when you take integral dE equals A is deleted. Okay, integral 2E gamma L minus X squared A dx. This one is integral. If you take from 0 to L, then this one is stored energy, strain energy, this one. Okay. In the case of right side, in this case same condition but it's different. P is acted like this one. Then E is different. Integral 0 to L to EA 1 and gamma L minus X A plus P squared dx. This value is what? This value is what? Store energy on the right cases. On the right case. Okay, slight difference of plus P. That's why we have different answer. Here we must know weight density. Weight density is multiplied here. Then you can have some forces you can get. In this example, we would like to calculate strain energy for the truss. And this truss is like this one. We have two truss member, and here pin is given, and the external force is applied like this one, and some angle and relationship H. Okay, in this case, normally strain energy is given by P, and if delta is given, then P delta is given like that. Based on this kind of relationship, we would like to know the change of delta at this point B. Okay, strain energy can be calculated P delta, let's say B, and in another principles we can calculate strain energy is in another method. U equals when you consider this one, then you can draw free body diagram like this one. Okay, then this angle is beta, and it's symmetrical, and this distance is H, and this angle is beta. Then this length is what? Let's say this one is, let's say L cosine beta equals H. L cosine beta, let's say this is angle. L cosine beta is H. If you have P value here, in this direction, we can separate like this one. Okay. This kind of force is acting like this one. Let's say F. And this one is beta, that's why F cosine beta in this direction. This one is F cosine beta. If we have two F cosine beta, this one is what? P value. F cosine beta, this one beta, and this relationship. Okay, we have L here, and this direction F. Then finally we can calculate this one. Let's say to EA, cross section is A, and F squared L. Then to EA, and F is what? P over 2 cosine beta squared L. L is H over cosine beta. And this one is equals like this one. Then we can calculate delta value. Okay, we can calculate delta. This one. based on strain energy, we can calculate displacement, or change of original form, we can calculate. Thank you very much for your watching.